Hey, good morning, everyone. Thanks for joining our LinkedIn Live session this morning on the topic of optimize your electrical maintenance. Primarily, it's more focused on know before you act. Today, I have our IoT application engineer with me, Bryce Brewer. He's online and he'll be explaining more so about the product side of things, which is a hotspot monitor, which we offer at Grace Technologies. And I'll be talking more so on the codes and standards, compliance requirements as it relates to electrical maintenance. Okay, so this is going to be like a 45 minutes to an hour long. That's what we're expecting this session to be. So if you have any questions as you are going through this presentation on a live, just type it in using the dashboard, or you can also share this if you feel that enough your network connections using a Facebook or LinkedIn Live. If you're watching this, just share and repost this so that others also get opportunity to know what's going on with this session today. Okay, so the first thing is basically why this maintenance is important when we look at from the safety standpoint or the codes and requirements standpoint. What is that compelling reason, right? We need to understand before you go and perform the maintenance tasks, you need to understand what's going on with your equipment before you're trying to put this maintenance task in place. So my camera again went off. I don't know. I'm going to be fixing that as well. Give me 1 second. I don't know why it's doing this. Hopefully this will fix it. Bryce, can you still hear me?
Yep, I can hear you, Banu.
Okay, so I think I came back again. So
yes, you're back.
All right. So one of the biggest things about the codes and regulations is there's three elements to it. One is the Occupational Safety and Health Administration's initiative as it applies to electrical maintenance or the requirements of the maintenance as it relate to this equipment, which is primarily discussed in 1910.333 subpart yes. The reason why it is important is when you look at the electrical fatalities in the industry, 1/3 of this fatalities primarily are due to the maintenance related equipment, which is primarily in the construction or maintenance and repair function occupations. So if you look at 1/3 of the fatalities, those are the result of this, right? And the second thing, that's from the occupational safety and health. Then you look at the NFPA 70E, which is electrical safety standard for workplace. There is one thing that's called condition of maintenance off. So in 2018 edition, NFPA 70E defined the condition of maintenance off as a requirement within that safety standards as well. So if you want to just look in the big picture, so the safety is like a three-pronged stool, as what NFPA says. So NFPA says basically there's one element which is primarily the installation requirements, which is primarily an NEC, National Electric Code, or NFPA 70. And then there is the safety related work practices, which is NFPA 70, right? So, and the third one is NFPA 70B, which is the recommended guidelines for performing the electrical maintenance activities around your equipment. So it's kind of a three different standards that comes into play when you're trying to accomplish electrical safety at your workplace. Okay. So, and the second thing they also talk about within this 70 years, maintenance has to be performed more so based on primarily on the manufacturer recommended guidelines. So if you have an equipment that's been put in place, and if you have the manufacturer recommended guidelines or the instructions that goes around it, you need to primarily focus on that specific requirements, because so manufacturers are the ones who knows how the equipment has been designed and then how to perform the maintenance task based on the performance criteria of that specific piece of equipment, right? So if you don't have the manufacturer guidelines, for example, you take equipment that's been 30 years or 40 years old, and then there is no manufacturer that's available existing for that equipment, what you would do in that case is you basically use the NFPA 70B standards, or you also use ANSI, NETA, MTS, maintenance and test specification. So these are the standard which you would use, right? So one of those things you would use on those levels. So primarily you focus on the manufacturer recommended guidelines, per the manufacturer on the record. If not, then we will go to that. Okay. So as I mentioned, is NFPA is maintenance and statutory requirements. Most people ask, do I need to perform the maintenance activities? Yes, absolutely yes. Because as I mentioned, from the codes and standards side of it, it is the responsibility of the employer or the owner of the facility to ensure that the equipment is maintained, to demonstrate that their personnel are not exposed to those hazards when performing maintenance around the equipment or when they're also performing any type of a normal operation. A simple example could be if someone is walking around taking a measurements, right? So taking a readings of the power monitor, power quality, or voltage, frequency, ampacities on this equipment. If this person is walking around that equipment, you need to make sure that this person is not exposed to any type of hazard under that normal operation. So I'm not talking about while he is performing a maintenance task around it. I am more so referring to what is being done on a normal operation when the person is walking around that equipment. So you need to make sure that equipment is maintained in such a style. Okay. So who is responsible for the maintenance? So most people ask, who is responsible for the maintenance? Again, there's responsibility lies with the owner of the facility or uh, the maintenance head or whoever is that, right? The employer takes the responsibility of the maintenance of that equipment, right? So, but the task that's being performed on that equipment, from the safety standpoint, other things, the employee also takes the responsibility once he's following the policies, procedures, and guidelines, right? But the employer takes the full responsibility to ensure that the equipment is maintained and that equipment is free of any known hazards, okay? So since we talked about the compliance requirements, the statutory regulations, and such, so how often do we need to perform this maintenance? So the biggest thing we face nowadays when we go and talk to most maintenance personnel are basically, so I don't have a definitive maintenance guidelines in place. And the second thing is, I don't have enough shutdown time provided by my management because I'm running 24/7 and throughout the year operations. So we can't take out that specific time within a work week or a work month or a work year for us to go and perform the maintenance tasks, right? So then the question is, how do you overcome those problems? You need to basically make sure that you have a proper maintenance program in place. I know it's hard because normally people don't find time to perform these tasks, but you need to make sure that from the statutory requirement, you have that in place so that you go and perform these maintenance activities. And secondly, based on the maintenance requirements as prescribed by the manufacturer. So the simplest answer is, how often do you perform the maintenance? It depends. The reason I say it depends because depends on your application, depends on your environmental criteria, and how much emphasis or the different types of loading factors taken into consideration. You need to come up with the maintenance requirement for that specific piece. It's a good example could be equipment that's running like 6 hours a day is not same if the equipment is running for 24/7. So these two things may be identical equipment, but the operation criteria is completely different. So you need to come up with the maintenance guidelines or the requirements that is set forth based on those criteria, and then you come up with that maintenance activities. Okay. So, and there's also a discussion about the criticality. I talked about the criticality environment, and the next one I would like to emphasize is a proper maintenance. So when you say a proper maintenance, it's not just having a visual inspection or making some adjustments or having your people fix on when the stuff breaks, right? So those are not the proper maintenance strategies. So proper maintenance strategies has to take into consideration the failure modes along with your operational criteria, and then come up with a plan, detailed plan on how often or how frequent you have to perform this maintenance tasks, okay? So I'd like to also emphasize one specific point, which is a normal operation that's discussed in NFPA 70E under Article 130.2.4, okay, which talks about 6 different elements one must meet to ensure that this equipment is in normal operation. So one of the things is you need to make sure the doors are closed and secured, There need to be no impending failure as it relates to the equipment. There is no physical hazards as one can see it physically, right, through your naked eye. And you need to make sure that you meet all those criteria. And then the manufacturer recommended guidelines is also one of the major pieces within that requirements as well. So you need to make sure that you adhere to all those 6 definitive steps within that normal operation to establish the fact that this equipment is normal operation. Otherwise, then it is not a normal operation. Then you need to have a qualified person. You need to follow all the other things around it, safety policies and guidelines to ensure that the work is being performed on that level. Okay. So one additional thing we come across is electrical equipment. When you compare different types of equipment in a manufacturing facility or industrial facility. So one thing we don't see is the electrical equipment doesn't get the same level of attention as normal other equipment. So for example, if you take a motor pump, or if you take HVAC equipment, if you take conveyor systems or any process related stuff, right? If you take those things and compare that with electrical equipment doesn't get much attention. I think primarily it's because they don't make any noise. You don't see any kind of a noise this equipment making out, right? So possibly think about a motor pump application. You have a wear and tear on the bearing, which is creating some level of noise or hissing sound that you can probably walk around the equipment and see it. And then you can have the maintenance strategies, and that's primarily a reason why more maintenance activities are being performed on the mechanical side of things rather electrical side of things. And I would say electrical side of things plays much bigger role than the mechanical side of things, because that's going to be your single point of failure. So you need to make sure that your main systems, like your transformers, your switchgear, your power distribution equipment, they're all functional and they're providing the power that's required to ensure that this specific rotating machinery are getting that. So once you lose that power, you lose the entire facility. So, and these things don't give you a forewarning and then go down as well. So that's one of the things what we normally see. Why this one doesn't get attention is primarily because they don't make noise. Electrical equipment, unlike the mechanical systems, they don't make noise, and that's how they don't see it, right? I think again my camera went down. I'm trying to fix my camera as I'm trying to talk. Give me one second. I think I should be back. Okay, I'm back again. Okay, in front of camera. Okay, so failures statistics in Hartford Boiler. I mean, Hartford Boiler came out with a failure statistics, which I want to show it on the screen real quick to ensure that you guys. So here is the bar graph. This data has been taken out from the Hartford Steam Boiler Insurance Company, where if you look at it, 30.3% of all these electrical failures are due to loose connections or circuit parts. So that's one of the top things. And the second thing is moisture. And the third one is line disturbance. So the top 3 causes of this electrical failure, as you see from this graph, is basically loose connections is the predominant reason. Because if anything on electrical failures is happening, that's one thing that you can avoid by having a proper maintenance strategy in place. So some facilities have a periodic inspections, as you can see. Some facilities do a periodic inspection on once a year or a 3-year basis, and some do thermography inspections and such, which is more like 6 months or 3 months or once a month basis. I think probably Bryce will talk about it. So what I'm trying to say is basically you need to understand what's going on with your loose connections or circuit parts to make sure that you're either monitoring on a regular intervals or you're also monitoring those on a timely basis, like once a year or once in 3 years to ensure. So one biggest thing that comes into play is, so whenever you do any kind of maintenance inspections, you need to have a proper record of it, because the documentation is also again very important when it comes to establish the fact that your equipment is maintained. So if you haven't documented that the maintenance has been performed, then it didn't happen as far as the codes and standards or the regulatory requirement needs, right? So you need to make sure that you need to properly document those, right? So one of the things last year or so, I spoke to one of the data center customers. So this guy spoke to him about one of our product offerings on the hotspot monitor, which Bryce will talk about in a few minutes. But what he mentioned was, I like this technology, I like this way of doing continuous monitoring of the temperature anomalies of the equipment. But one thing is, I don't have a shutdown so I can put it back, the systems. So the question is, they haven't turned the systems to off position in like last 10 years. So my question is, do you want to take a shutdown on your schedule, or do you want to take a shutdown when it goes down on its own? So there's a day and night difference, right? So once you take a shutdown based on your convenience, you probably manage all your resources. You have the people in place, you have taken a backup systems to support your needs and everything. That's more like lesser time where you can get these things done, right? On retrospect, if things go down in a chaotic mode, then you're basically looking for resources, you're trying to expedite the systems, you're trying to make sure that you have the people in place, and then you have to take a different levels of approval to make sure that these things are installed. So that's kind of what I was trying to allude to. So I mean, loose connections is one of the areas which Bryce will be talking about. With that, I'll ask Bryce to talk about different types of technologies that's available in the marketplace when you look for the temperature anomalies and what those pros and cons, right? So I'm going to be playing neutral here. When you take any technology, there's going to be like pros and cons that's going to be given with any type of technology. So let it be the limitations of the technology itself, or the limitations of the measurements what you take, or the limitations that shows on your people and resources that you have available. And the last but not least, how do you make the systems work or complement your existing systems, right? Whenever we talk about any new technology, so every manufacturer is going to come and tell you, okay, you can go on this card, everything what you have in place that you have maintained in like 30 years, and you put all these new flashy things that are going to solve your problem. So what we're going to talk to you today is how you can make use of your existing systems while still implementing the new technologies and making it more efficient. That's going to be the theme what Bryce will be talking about. So with that, I will let Bryce give you an overview of what Grace Technologies does from the product standpoint on temperature anomalies detection and how it will help you to do it more so in a safer and efficient manner than what you would be doing otherwise. So.
Absolutely. Yeah. Thanks for the introduction there, Banu. Thanks for setting the scene here. So there are a lot of different technologies out there on just general temperature. You know, you've had RTDs for years and thermistors, thermocouples, but none of them have really been catered towards an electrical connection. So the market has come out with a few different options in order to address this. So I've seen technologies where it's like basically a permanently mounted IR camera that's inside the cabinet that's looking at the connection. There are your typical thermography scans that are done on a monthly schedule using either open door or closed door thermography. So Grace was looking for a solution that was permanent but didn't have some of the different failure points that a camera might have, of field of view, making sure that it stays clean, being able to easily just get a temperature value. So what we came up with was we have the hotspot monitor that you see right over here. So this hotspot monitor, that would sit in your low voltage compartment on your switchgear or your MCCs or anything like that. And then we'd route out these fibers. So you see these yellow, they're optical fibers that go out, and then you can bolt them on your connections. We're kind of zoomed out here, but basically you just take this fiber, it goes onto a ring lug, and you can bolt it onto any of your connections that you're interested in. So, we can definitely talk a lot of detail on what exactly we would monitor. We do one-line drawing evaluations for our customers, but some of the big hitters that we like to mention is your incoming is important, and this is on both medium switchgear. This can go up to 80 kV, so that type of switchgear, as well as some really critical 480 systems as well. The incoming is important. Any shipping splits where the different gear come together, that's a potential point where they can come loose. So that's somewhere we suggest monitoring. And so that's some of the key things. And then you look at what your loads are, how critical they are, how often they're running, to determine kind of from there what other points do you want to bring in. So yeah, you have a question, Bunny?
So Bryce, why don't you explain how different is GraceSense hotspot monitor compared to a traditional thermography program, right? So normally industries,
Yeah.
when we come across the facilities, they do the thermography programs for detecting the temperature in amylase. Do you want to elaborate on that, please? How it is different? Can you compare and contrast?
Absolutely. Yeah. So thermography programs, they've been around for a long time, and some places use them for different reasons. So some are just checking a box for insurance purposes, right? And other ones really do try to get an idea of what their switchgear or MCC health is. But the real difference is that that's on a monthly basis or potentially less than that. And we don't know the condition of the loading. So was this at peak loading, or did we take a look when half of the plant was down? Which oftentimes is the case, because they decide to do a thermography scan when it isn't as busy in the facility or during a shutdown time. We have had customers do it when most of their gear was down. So that's the big difference. There's also field of view limitations. So for a closed door, you have your different viewing windows, and you might be able to see 3 connections from there. Or you might have individual windows for each connection. So there are cons to putting those windows in to maintain the ratings of your gear. You have to have it recertified. And then there are things that you can't see. So anything behind any kind of guarding, obviously with a camera, you're not going to be able to see that. So you might have to opt for open door thermography, which is obviously less than ideal. Having running gear while you're trying to get thermography scans is not the best practice. So this hotspot monitor can be bolted onto any connection behind any kind of guarding that you wouldn't normally be able to see from the front. And we're also capturing this 24/7 and being able to see that over time under every loading condition, and let you know via a variety of ways what your potential issues are.
So 2 additional points I would like to add on to what Bryce mentioned is, when I talk to facilities about thermography programs, the 2 things comes into play. So one is they don't have internal resources who are trained to perform this task, right? So then you're bringing in third-party contractors, which is a great way to address the situation. However, people think when they bring a third-party contractor, they are deflecting the liability standpoint from the facility to the contractor, which is not. So from the legal standpoint, if a contractor is performing a task or a maintenance function at your facility, so it is the facility owner's responsibility to ensure that these people are safeguarded against any electrical hazards. So that's the one thing.
Yeah, that's a very good point there, Banu. Definitely having the liability still when you bring in those different contractors to do the work does change kind of what a lot of people think. If we had someone who came and looked at this, then they're ultimately responsible for their own safety, and we're going to be able to ensure that we have a reliable system because we had a third-party contractor take a look one time 3 months ago.
That's true. So the second one also we'll say is how often you are performing this, right? So not the worker qualification comes into play. So anybody who is walking with an infrared camera, I think nowadays with the COVID-19, you can see everybody carrying one camera to monitor our temperatures, right? So you go to any fitness centers, or if you go to any stores, there is a guy. I was at a hospital the other day, and then there was the lady who was just using an infrared camera to just monitor the temperature. So, you need to understand that people are certified thermographers when they are performing this maintenance task. So this is not something you just shoot this, point this gun at an asset or a connection, you can take the measurement. You need to make sure that you calibrate this and then understand the transmissibility settings within the different types of elements when you try to use that as well. So I think that's an additional point I would like to. And last but not least, whenever you make this type of thermography programs and you're trying to do anomaly checks, all you're getting is the timestamp. So you're getting that temperature data of that specific point in time. So you're not getting what's going on 2 months before. You're not getting what's going to happen from then to 6 months down the line. So you can only say what is happening at that given point of time with that predetermined load criteria, what's been subjected to at this point, right? So you can get the continuous points of data like what Bryce was talking about. So I thought those are the important points that I would just try to explain. So, and one more thing Bryce explained was about the transmissivity settings, right? Not the transmissivity, the field of view settings. I'm sorry. The field of view is the one thing which takes a bigger importance as well. So if you take this IR camera and you then shoot it through a window, or if you have the open door thermography where the person is performing this thermography task, so either ways, you can only see through the camera what you can see through your naked eye. So you can't just go through some of this geometries inside this cabinets to see some of those connections, right? So that's one of the points I would like to make. Is basically a field of view from this slide, as you see in the screen. It's only restricted to what your camera can see within that visibility range. Okay, so that's the one thing. So, Bryce, with that, why don't you go and explain some of the main features and functionalities of Hotspot Monitor?
Yeah, absolutely. So one of the things Banu did mention before was how this type of thermography, it needs to be done, continually. You can't take a snapshot and be able to know what happened between the two scans. And it's very important to know what happens over that time. So from this slide, you'll see the inaccessible locations, once again, that Banu and I both mentioned, but reduced risk is a big thing. So especially in those open door thermography, that's a large risk. And so I would encourage any employer who is needing to perform those, evaluate how necessary is that? Is there a better way to do it? So from there on some of the hard specs, so these fibers that I mentioned that come from the head unit, they can be up to 15 meters long. So you can go 15 meters in either direction. So it has a very large wingspan. We have a 9-point unit that you see here with the screen, and then an 18-point unit that does not have the screen. The big things about these is that the data can be exported in a variety of ways. The simplest fashion would be you can do a route and grab the data, just pull a CSV file once every 3 months or something like that. That's not the ideal solution. Ideal solution is to have it integrated into your SCADA system, DCS system, your control system. Wherever you want to see the data, we can probably get it there. So we have Modbus RTU output, as well as Modbus TCP IP and Ethernet IP output. So there are a variety of ways to get that out. The device is just powered by 24 volts, so it in that low voltage compartment, and it's DIN rail mounted. So those are really the high notes there. It is up to 80 kV as well. So yeah, that's the most on the specs, Banu. Is there anything else you wanted to add?
I would like to know the temperature range and what kind of things that will do, right? So there's a temperature range. There's accuracy is one thing which customers mostly ask, right? How accurate the information they're spitting out.
Yeah. So the accuracy is plus or minus 2C, which is more than sufficient for this type of application. And the temperature range is slipping me right now. I reviewed that just before this, but I can't remember, Banu. I don't have my data sheet in front of me. So
what are you talking about? You're talking about
the temperature range.
Temperature range from minus 4 degrees Fahrenheit to 248 degrees. I show it on the screen right now. And then we also have a high temperature probe that will take it up to 320 degrees Fahrenheit.
Yes, yeah, and that high temperature probe, it basically just extends that connection away from that point to where you can get the higher temperatures. And from an application side, I haven't had a lot of customers who have used that. Typically the standard is fine, and when you're getting up that high, even if your gear is running that high, in most cases it shouldn't be. There should be an evaluation to make sure that it's within its operating range. So I would definitely contact the manufacturer of your equipment and make sure that the temperatures you're seeing are within the specified range.
Okay. Now that's a good point. Do you want to show? I'm just going to present this on the screen. Do you see the screen, Bryce?
Yes, I do.
So do you want to explain how it works?
Absolutely. Yeah. So from the head unit here, it is a fiber optic out to the connection point. So it sends a LED pulse from here. It goes out to the tip that is right there on your ring lug that's on the equipment. And so that has a phosphorus material in it that basically will change its reflective properties based on temperature. So that will change based on the temperature, then it's reflected back to the head unit where it's red, and that's where it's able to determine what temperature it is, all non-conductively from the low voltage compartment.
Okay. No, that's good. I mean, how do you want to expand upon? So we talked about thermography, right? So we talked about thermography. There's a limitation. So what is the limitation with this unit?
Yeah, the limitations are, you only see the local spot. So heat will travel if you're doing like a bus bar application. It will travel some down the bus bar, but it can be difficult to determine. Okay, so if I'm at a certain temperature, is this, and I'm trying to pick up a remote location, that's really not the ideal thing, because trying to determine what is an alarm level there can be difficult. So that's one limitation. So we do have 18-point and 9-point units. So just making sure that, if you want to do three points per monitoring, so your A, B, and C phase. So just making sure that you have the right numbers to meet the need, and that you have room in your thin rail in your low voltage compartment would be another thing. Those are the main limitations that I've come across. The fiber as well, it is a PVC coated, so and UV will break it down. So if you are in any type of outdoor application, some kind of conduit, be it rigid or flexible, should be around that. So that's an important part. It can't be in oil as well. So if it's an oil transformer or something like that, that would be somewhere where you need to not be, at least have the fiber into that oil. And then the bend radius is a 1/2 inch, which that's just a part of the installation process, but it really doesn't come into effect when you're, it's usually not an issue. And then we can get into really the nitty gritty here, I think, are the next slides on kind of how it's installed. So I can talk a little more about some of the other precautions you might want to take. So here are some of the different applications. But so from any of those connected points, the nice thing is we're not changing how the equipment was originally designed. So we're basically adding in a ring lug that acts as a washer, so you can bolt and torque it down just as you would before. And you can reboot that connection and just have the fiber come up through there. When you are going through the compartments, we do suggest to gather them together, but at least like 12 inches from the point that it's connected to. And that's for, making sure that, we have a grounded surface and that there isn't dust accumulation. You don't want to go straight from the phases and connect together. So to go up all to a different point and then run them back to the head unit. When going through different compartments, it is nice to have some kind of protective cover around that, as well as definitely protecting it on any kind of bends around sheet metal. So if you have a sheet metal edge, over time that could potentially, wear it down. So definitely putting some kind of either foam or something like that around that connection, or having the protective conduit, flexible conduit, or something like that.
So what happens? I mean, what happens? How do we know, right? So once after installation of the system, how do we know if this device is actively monitoring the temperature of that specific channel? For example, if channel 3 or channel 7 is monitoring temperature, you see it in some dashboard, correct? So
Yep.
how do you know whether or not it's monitoring it? So what in case if this polymer gets disconnected? What happens in that case?
Yeah, so there's kind of two things that revolve around that we have addressed. So for one, if it's unplugged, you'll get an error. So if you just don't have any fiber connected, or somehow it got someone cut it or something like that, you will get an error back through the unit. So if you have it in your SCADA system, it can send an alarm that way.
Okay.
As well as we do have fiber power indication. So, if you have routed these and you put a ton of bends along the way, it usually will work just fine. But if you plug it in and you see a value of, it's a number from 1 to 10. If you see anything below 7, I would try to address the routing of the fiber, potentially cutting it again. So I also didn't mention that these are a polymer fiber, so you can cut them to length and you don't need to polish them or anything like that. So you can just recut off, say, a 1/4 inch, 1/2 inch, and then reinstall and see if that reading is right on the device. If it's a 9-point unit with the screen, or if it's a 18-point unit, you can connect with your computer to get all those values.
So from the installation standpoint, I would like to add one more point here is revalidation and listing and labeling requirements. So one of the things that becomes a big question when you go and implement any new piece of technology or a device into an existing gear. For example, you have medium voltage switch gear. So you want to add this hotspot monitor, or you want to add IR window, or you want to add any of the new technology. The first thing is, customer question is, so what will happen to my listing and labeling requirements of my existing gear, right? So as long as there is any kind of a design impact of that new system on your existing gear, so it should not be really a problem. For example, for installing a window, if you're making a huge 6-inch cutout to install this physically, then you need to make sure that that window is meeting the short circuit current ratings of that specific cabinet, one thing. And second thing is, it also needs to adhere to any kind of distractions, that's structural integrity test. You need to make sure that structural integrity of that gear is not compromised while performing that, right? So the other question is the equipment is under manufacturer warranty still or not, right? That makes a huge difference. If you have a switchgear from a reputed manufacturers, and if you have, like, within the 3-year period, within that warranty timeline of that manufacturer, you need to make sure that this one is implemented, whichever the new technology you implement, hotspot monitor or this. We work with all the major switchgear and power distribution manufacturers. So integrating our equipment with that is not a big problem. So you can definitely go back and verify to ensure that if it voids any kind of a listing and labeling requirements. And if it is out of warranty equipment, so then the question is, are you trying to use this to enhance the safety and productivity of your employees, or is it going to create any kind of a negative effect, right? So you need to make sure and you need to evaluate that from those sides to ensure that this is applicable for your situation. So if you want to answer this question from a politically correct statement, so you need to ensure that after you make any modifications to your gear, you need to ensure that you go and relist your equipment. That's the correct procedure. So when you call the UL inspector or the local authority who's having jurisdiction come and inspect it, they will give you with this amended changes, ensuring that the system doesn't violate or void any of that design parameters or the criteria that this equipment has been originally designed to. So that's kind of the top level point I would like to make on that. So, Bryce, you talked about the hotspot monitor. You talked about the continuous monitoring of the temperature and such. So, what do I do with my existing infrared cameras or thermographies and such? So, do you want me to, I mean, from the facility standpoint, do you expect someone to put this hundreds and thousands of channels on every piece of equipment, or do you have any recommendation on what would be the optimal or ideal points for this installation?
Yeah, it's a
I know that we all would love to sell more of this in quantities, right? So, so what is your recommendation from that standpoint?
yeah, that's a very good point, Manu. So I would say definitely do not throw away any of your equipment, any of your IR equipment, because this is really a complementary package with your IR program. I wouldn't try to outfit an entire facility with this type of equipment. Really, it comes down to a criticality analysis. So making sure that any of your key points that you couldn't live without are monitored. So that's where we'd say to start. And that doesn't mean that you on the auxiliary type power distribution, that if you already have your IR window there, go ahead and continue to do those inspections. We'll tackle the key ones with the hotspot monitor in order to get that on a continuous basis, and then potentially you can expand that, but it doesn't mean you have to do one or the other. It's definitely works really well in a complementary relationship.
Okay, well, that's good. I mean, they can. So, do you want to explain a little bit about the networking communication protocols? You touched a little bit about it will communicate to the existing DCS or SCADA systems. Do you want to give a quick overview of how this works and what is the communication protocols this will support, and what is that physical connection points to this as well?
Yeah, absolutely. So the device does have an RJ45 port at the top where you can easily put that into a switch, and then you have your Ethernet IP or Modbus TCP communication. So if you want to bring this into, say, a Rockwell control logic system, we do have an EDS file that makes it very easy, that does bring in the tags fully named to where you can go ahead and bring that into your program, and then you can choose how to use those tags. It does have an onboard ability to do an output as well. So you could just very simply set up the alarm threshold and then have it send a trigger to a stack light or into the control system. So that's another option. One thing I do like to point out is it does have Modbus RTU. So that's good for any legacy systems, as well as we do have some other offerings in this space that will accept the hotspot monitor as an input as well. So using that Modbus RTU. So do you want me to dive into that now, Banu, or would you like me to touch on that a little later?
Yeah, I mean, you can just talk about it now, yeah.
Yeah, okay, great. Yeah, so from the Modbus RTU side, that can be brought into a cloud-based system as well. So we have our GraySense predictive maintenance line. So the hotspot monitor is a part of that, but it can be absorbed into the rest of the product line. So that way you can have a central location where you can bring in multiple of these hotspot monitors and be able to view the trend over time, set up alarms that go out via email or text, that type of thing. And then there are, from the rest of the family, there is, vibration monitoring for motors, and Banu touched on that. Those are the high attention items, right? So those are the things that the facility is usually keyed in on to monitor. So that's why we like to bring that all together, where we can really bring some awareness to the electrical side that's often kind of neglected.
Okay. So you can communicate using a Modbus and also Ethernet IP, as what I'm showing on the screen, I guess, right? So
yeah,
with which you can set the notifications. So, I mean, the biggest message, I assume, Bryce, here is you are continuously monitoring the equipment. and then you are taking any kind of a preventative maintenance action as a result or a function of those anomaly detections. So a simple way to put it is, do you want to take your camera and walk around this equipment on a monthly basis, or once in 6 months, or once a year? That's specific things that which you can do using a thermography program or inspections for everything, right? So, but you will also identify certain critical assets, which is critical for your application from the process standpoint or throughput standpoint, and then you monitor those more so on a closed level to ensure that the anomalies are captured not only from the temperature standpoint, but also you take the other elements of that same asset, right? So, like Bryce was telling about, a predictive maintenance system not only monitors your temperature anomalies through just a hotspot monitor, you also have what I have on screen here is you can take other parameters like your voltage, frequency, current, power monitoring, and everything, and you can bring it all into a holistic fashion to a single dashboard where you can do some level of a correlation. So do you see anomaly height as a result of something else, or is it standalone, or is it one of this erroneous functions, right? You can understand in a better terms of what's going on with that specific asset once you have all those elements streamed to a single dashboard. That's kind of what I understand from this overall system, right? If I want to use the same system, Bryce, on a standalone basis, correct? So this also has a web interface, I guess, correct?
Yeah, absolutely.
This has a web interface. I think I want you to explain, because not every customer or every facility wants to have a DCS system or a SCADA system or a complete end-to-end solution IoT. So if a customer wants to use it on a standalone basis, this is what I'm showing on the screen, correct? There's a web utility or interface. Do you want to explain how this can be configured to meet that independent use of the product?
Yeah, absolutely. So the way that you would go to set up one of these devices, so you can plug in right from your computer using an Ethernet cable, and be able to bring up the HSM web utility that you're seeing there. So the web utility allows you to put in, IP addresses. That's where you would set that up. So it's kind of a tangent from what Banu was saying, but this is where you would configure your IP address here. But for a standalone, you can go in and set your alarm thresholds. And so that's great if you want to do that local alarm output. So this thing can be, sitting, not connected to any other system, and it just is connected to a tower light. And if it goes red, someone's walking by, okay, well, what's going on here? Check it out. And then you can, put in different warning and alarm levels. So if you wanted to have some connections, run hotter, because there's, that can be adjusted where you have two different warning and alarm thresholds. And then you can go around, as I mentioned before, and just pull a CSV file from this. So it can log every minute, and it will, or you can do it like once an hour, once every 10 minutes, whatever you want to do. And it'll store months worth of data. At the larger settings of like a year or every hour, it'll do years of data. So that's kind of how it would work on a non-connected system.
Okay. Well, that's a good overview on that end. I just want to quickly talk about, I was involved personally from Grace to work with one customer case study application where we met this customer at one of the trade shows or events a couple of years ago. And then these guys came and looked at our product, and fast forward. So these guys thought there was a huge interest because it will solve some problem. And I had the opportunity to work with them closely to understand what's going on and what really triggered them. So I'm going to just talk about quickly on that end. So this is basically one of the customers I met at NETA conference, which is a power test electrical maintenance conference. So this is in 2017, I guess. So these people, this is the food and bev manufacturer. I can't disclose the name. So they had a 3,200 amps breaker. And the problem was basically they had this breaker failure on a more frequent basis, once in 6 months or so. And they were having thermography program in place, and they were just looking at all this visual inspections or physical periodic maintenance checks on this equipment. But in spite of all this, they were seeing recurring failures on this breaker. So what they did was basically this use this more like a diagnostic tool, not like a permanent solution. They tried to use it as a diagnostic tool to understand, okay, am I missing anything? Because this gives them a temperature monitoring capability on a continual basis. With thermography, as Bryce mentioned, they couldn't get it. So they were able to hook this up for 3 months. They just bought this product and they just deployed it, and they temporarily connected the system to monitor the temperature anomalies. So what came out from that was basically they saw a lot of load patterns. So they see the loads are not being staggered. They're looking at 400 horsepower motors, which is drawing 2100 amps, going on like a sequential starting. There was not sequential, everything coming up at the same time, which was creating that temperature hikes. And also the second thing they noticed was the impact of the 11th, 13th, and 15th order harmonics as well. So one of the things which I forgot to mention is temperatures, not only because of the current rise, it could be also because of the harmonics as well that could lead to temperature rise. And some of the instances where with the extensive use of variable frequency drives and such, you're going to see more of this harmonics involvement when it comes to temperature anomalies. So these guys were able to detect the temperature anomaly because of this hotspot monitor. So I was involved in this project where they were monitoring temperature because with the web interface, which Bryce showed you a few minutes ago, there's the ability where you can monitor this. You can set this based on 1 minute. That's the lowest you can go, right, Bryce?
Sure.
Yeah, you can go on a 1 minute thresholds or 5 minutes or 30 minutes or however the frequency you want to go. You can preset those. So with which they're just constantly monitoring. So what happened was this equipment, as I mentioned, there's no one size that fits all. So this facility was 24/7. They were not able to do the same with the thermography camera. With hotspot monitor, they were getting everything based on the timestamp, and they were able to go back and check the process parameters and the loading patterns of that specific equipment as they relate to this piece of device, and that showed them this inconsistencies. So basically, they used it more like a diagnostic tool to evaluate their problem, what they had, and then they went to the process level and changed the sequence of the loads as they come up to that specific 3200 amps breaker, and that's how they solved this. So, I mean, continuous temperature monitoring is not just a permanent solution that you need to have it on critical equipment. You can also use it as a diagnostics tool, right? So, do you want to expand upon that? Having that fiber installed, Bryce, just because what in case if the facility wants to deploy this on many of their equipment, but they don't want to spend that huge initial investment because most of the management is going to push back, right? So before you can justify an investment, they're going to ask you, show me what is broken or show me the real value, right? So how do you justify that? This is one of those areas where you can use it as a evaluation or a diagnostic tool. You can show the cost of avoidance, specifically when it comes to that temperature anomaly and which result could have resulted in a failure or a shutdown, and that could be justified. So how do we address those situations, Bryce?
Yeah, so I think there's a few different situations you brought up. So for one, if you're in a 24/7 facility who doesn't have downtime, scheduled downtime, what we often suggest is just to buy some of the fibers and have these guys just sitting on the shelf. So what that allows you to do is, if you did have an unplanned incident, you could go ahead and install these and start to route them back to the low voltage compartment. And then, while you're having that shutdown, to where you're not having to have a whole bunch of inventory on the shelf, but you're able to get that installed when the equipment is down. So that's definitely a big part of that. And then, was there anything else you wanted me to touch there, Banu? I think that's the main point. But what else did you want me to hit on?
No, that's pretty much what I was looking at. I mean, the dark fiber is basically you have a maintenance shutdown, you can install this. The primary advantage is having this a non-conductive fiber. You can have the one end that's making a physical contact to the board, as what's showing on the bright background on the screen, right? So the other end is basically your polymer fiber that will feed into that module that sits on the low voltage compartment. So this can be drawn all the way to low voltage compartment, and you can take this device and you can rotate it between the equipment. That's what I was trying to look for. Basically, is
Yeah,
facilities can have the fiber installed. Like I have this 15, 20 pieces of gear, but I can have fiber installed on all these pieces and brought into that low voltage compartment, and then you can take few of those devices on the module itself and you can mount it, put it on a DIN rail channel, connect to auxiliary power, because you're not dealing with anything on a 480 or a medium voltage at the point, right? So everything on the low voltage compartment where you can completely isolate and still be able to get the value of it, or use it as a diagnostic tool to understand what's going on with that system too.
yeah, yeah. Good point.
So what type of integration? How do I mean if I want to install this equipment device at my maintenance facility, and how do you support it? I know that we do have this hotspot monitor standalone devices, 9 point, 18 point that comes out from factory with the fibers and sensor leads and such. So from installation standpoint, how does that work with the end user facilities?
Yeah, so there's a couple things there. One, we like to be a partner with you and help you determine where are we going to install this. You can say I want, this is my critical piece of switchgear, but do you want every point monitored in there? Do you want us to help you figure out what are the most critical ones? So that's kind of before the sale even happens. We need to identify what we're going to be monitoring, and we're happy to help address that. I know myself and Banu have sat down on quite a few of these one lines and just determined what we think are multiple different levels of from optimal coverage to kind of a minimum level to kind of all the way blown out. So that's kind of at the onset, and then from there we'll be able to assist in providing any of the documentation around the installation. So your installation guide, quick start guide, your kind of integration manuals. So we will provide that. We have been on site, for any of these large installs. We can be on site to make sure everything goes well, answer questions, make sure that it's being installed per our guidelines. And then we do have resources through our distribution network as well for if you did need to have that integrated. We can get you up and running by getting the tags, making sure that you can get the hardware into your control system, and then have all your tags loaded, and then either an integrator or a distribution partner could work with you to write any of the alarming that you want to do. And it can be very simple on the type of alarms that you want to run. It doesn't have to be a full blown, it's not a control project we're talking here. So it can be a very simple one that we're happy to help with.
Sure. So do you also want to expand or give some insights about how hotspot monitor ties in with our Rockwell Encompass arrangement too? So you want to just talk a few points on that, Bryce?
Yeah, so Grace has been an Encompass partner for like 22, 23 years now. So we're very well ingrained in that. So that's why, having Ethernet IP on all of our smart devices is a big thing for us, and making that seamless for them there. So the EDS file is it's very customized to where you can choose what connections you bring in. So you can just bring in Fahrenheit if all you care about is Fahrenheit, or Celsius if that's all you want to look at. You can bring in the alarms that are based on the system, or you can, but based on the system, I mean in that web utility we showed, you can put in alarms. So you can bring in those type of channels, or you can choose just to look at the tag of the, the third point, the temperature in C, and grab that and use that in your program to evaluate against. So That's all from just a drop down, choosing what connections you want to bring in. And the big thing I like to say there is that just having the tags named, that's a huge part of anyone who works in controls knows that if it's matching, registers, that can be really frustrating. So we try to make it as easy as we can for you guys.
Sure. So one question, I think probably you know the answer. So can we use this product for temperature monitoring, for the winding monitoring? So take a temperature, can we use this to monitor the winding temperatures in a transformer application, or can I monitor the winding temperature of a motor or a generator? So I think there's a lot of misconceptions. I want you to clarify on that too. So
yeah, Banu, I haven't had an application around that. I know I've done motor leads, so I don't want to say that you can. So it seems like you know the answer, so I'll let you take that one.
So this is not meant for monitoring the temperature of the windings. This is all surface contacts. If you're really monitoring the temperature of a transformer winding, an oil-filled transformer, so this product will not work. You need to have a glass fiber that's specifically made to work within that environment. So this one is primarily for busbar temperature monitoring or any kind of temperature monitoring on the terminals or the surface contact only. Okay. So for motors or generators, normally they have this RTD options, which you can order the motor or generators with, that will monitor the temperature. So this is not for that. This is primarily aimed at your switchgear, your power distribution system, monitoring the connections of the bus bars or monitoring the splices. So where you can take the advantage of the continuous monitoring and then use more like a maintenance on demand. Okay. So that's kind of what it is. Any other points we missed, Bryce? I think I have a few other things I want to talk about. So anything else from the product standpoint you think that you want to emphasize on?
No, I think that pretty well covers it. It's the big thing here is we're talking non-conductive 24/7 monitoring. So that's kind of something that we think is very important, and we hope you guys do as well. So hopefully you'll learn something from Banu definitely, and hopefully learn something from me.
Yeah. So a few final thoughts are basically any kind of a tool, right? So any type of a technology or a new tool or a system, whichever you choose to use, it's not going to replace your manpower or the human intellect. So I want to just make sure that these things have been designed to make the maintenance personnel more efficient and then keep them safer while performing these tasks. That's the premise of this, right? So a lot of people think, do I need to throw or trash everything what I have today for the last 30 years? Not at all. So you always need to pick the technology or any kind of a tool that will complement what you have already and build upon on that. So that's the major point I would like to emphasize on, right? So the second thing is remote monitoring tools, is what Bryce has mentioned with the hotspot monitor, will greatly help you to take that exposure from that in front of the maintenance person. In simplistic terms, the far away you are from that hazard or the exposure, the better you are getting into an incident or an accident if something were to occur. So having this continuous remote monitoring tools keeps the distance from that asset, so you can remotely sit in a control room or in front of your laptop and still monitor and then actually manage it without the need to getting in front of it and exposing, right? So yourself. And last point I would like to make is any system is not going to fail by itself. So one thing I talked previously is periodic maintenance. As much as I can emphasize it's of a great use, over maintenance or too much maintenance can also have a negative effect on that equipment, because every time you try to disassemble a piece of equipment and try to put it back on, there is always a component that's called a human-induced error. So you need to make sure the less you touch the piece of equipment, any type of the condition-based monitoring tools are going to give that ability to monitor the status of that asset, so that you go and deploy this personnel and physically come and interface with that asset on demand basis or when there is a need for it. Not looking at disassembling it, putting it together. Think about the torque requirements on the splice connections or the loose connections of the bus bars, right? So because whenever we have a human interface with a piece of equipment by performing a task, you're going to interject that element of error, right? So the less you touch this, sometimes it's better it is. So, and lastly, I get asked this question a lot. Will all these tools help you to increase the reliability of your existing systems? So this is a tricky question. I want to answer this, right? So maintenance will not increase your reliability numbers. The reliability is defined at the design phase of the equipment. The equipment's reliability has been defined at the design phase itself. Any type of the maintenance strategies or condition monitoring techniques or whatever you do with that after that is going to ensure to maintain that reliability number. So there's a misconception. Doing too much maintenance is going to improve my reliability number by X, Y, Z number, which is not. Okay. So all you can do is by doing this, you can guarantee that reliability number to stay the same at that level. You can't increase the reliability number by doing too much maintenance or less maintenance. Okay. So any kind of a maintenance activities will lead to maintaining the reliability level to which the design equipment has been designed to originally. So to conclude this, I would like to bring in this slide, which is my favorite slide. So many organizations look at safety, reliability, and maintenance or as three different entities. So which is totally, I mean, because if you look at the safety, people in the EHS teams of the facility manage that safety piece. They say that's my responsibility. I need to make sure that there's no incidents at my facility and such, right? So reliability is basically the throughput, the operation of the facility to make sure that there is no shutdowns. They need to make sure they produce the product what they're tasked to do, designed to do that, right? And then the maintenance is like the bottom layer, which is like the tactical level. So maintenance people look at, hey, I have X amount of budget on my maintenance, so I can only spend this. But these three things historically has been dealt as separate entities. So what I'm going to tell you today, the takeaway from this is, these are all interlinked or intertwined together. You need to make sure you look at it. These three things contribute to the same organizational goal, right? So as you look at the maintenance is at the bottom of this pyramid, I'm trying to say the maintenance activities has to be done to ensure that you achieve the design reliability requirements of your facility. Okay, so the maintenance basically sustains your reliability, and by having a reliable plant, you can achieve your safety metrics. So that's kind of where it is. So safety is like the top level message. People try to see it in a separate bucket when it comes to budgets and spends. So whenever you go to any of these design meetings or designing a new equipment for that matter, so you need to look at all these three pieces, look at from the total cost of ownership while taking all these three pieces into consideration. That's one of the things I want you to take away primarily from this is, there is no single bullet like this product is going to solve this problem or one product is going to take out the other systems what you have in place. You need to make sure that you have everything that works cohesively in one piece to get the best outcome from your assets. That's kind of what I would conclude with. Any other questions you see, Nick, on the stream? Or if you don't have any questions, you guys can get more information about the hotspot monitor at www.gracesense.com. And there's our website on the screen, gracetechnologies.com. Is a corporate website. You can get more information about the products. You'll also see a live chat where you have inside sales teams will be happy to answer any type of product questions you have. And as Bryce mentioned, myself or Bryce can definitely get in touch with you if you're interested about learning more about the product or the application of how this can be successfully deployed at your facilities. We'll be more than happy to talk to you on one-off basis as well. Okay. Thank you so much for your time. And I think we can conclude this. Any questions you see on the screen, Nick? I'm not monitoring the questions, so.
Yeah, I don't see any questions there, Banu. So I think we're good to conclude here.
Okay. Thank you so much, guys. Thank you so much for your time again. And we look forward to seeing you guys on all our webinars and LinkedIn Lives. Please feel free to share this links with your network so that people know what we're doing here at Grace. Thank you so much.
Yep. Thanks. Have a good one.
Bye.